So I will just quickly, 15 minutes, we'll quickly run through what we covered in last one class. You have doubt, ask, okay? Otherwise, I will assume it is okay. And let me tell you, this is an important session. This is an important part. This decimal binary business is an important part. This is something which you have in syllabus. It will come to you maybe in 11th and 12th, if not in 10th. And this will come to you in computer programming. And one of the first computer program which they will ask you to write is to conversion. Binary to decimal, decimal to binary. Whether it is microcomputer or a processor. Okay, so this is this trick, and if you later, if you want to get into computing engineering kind of stuff or into the core of it, you will need this knowledge to see how things work at a binary level. Okay, so this is important. That's why last time I asked all of you to go and study the evolution of microprocessors, 8-bit, 16-bit, 32-bit. I didn't see anyone submitting that, but see that. Okay, fine. And Avinash, nowadays, the computing knowledge is essential. You go to any field. The times have changed where you have to know computing and computer engineering if you go for computing. Now you need computer engineering in almost everything. Well, you may not have to design a compiler, or you may not design an operating system kind of stuff, but basic programming, coding, basic understanding is part and parcel of all the jobs nowadays. Yeah, okay, that's what you have to understand. Now you see, this we told, very simple thing. Now don't ask what is the importance for 2 and 5. Okay, there is no importance. I just picked a random number. Okay, so just a random number. So we told 5s are 10 raised to 0. Yeah, welcome Anush. And then its value is 1. So the total value of that digit is 5 ones or 5. This is LP class, okay, class 3, class 4. And once we told is 10 raised to 1 is the place value, or 10s are its value, that means its value is 1 into 10 or 10. Then we told 2 place value is 10 squared or 100, so that is 200. Isn't this how you are learned in LP, UP and all? So 215 is 200 plus 10 plus 5, right? You have learned 200s, 110s, 5 ones. Now if 1000 position something is there, that many thousands. So you know this. Now go to decimal side, same thing. 4 is 10 raised to minus 1 or 1 by 10. So the value is what? Value is 0.4, right? The value is 0.4 because it is 4 by 10, right? So second position, place value is 10 raised to minus 2 or 1 by 100. So what is the value of this one here? What you will add to 0.4? If this is 0.4, if this is 5, if this is 10, this is 200, if this is 0.4, what is this value?
0.00.
0.00, right? 0.00. And what is this value?
0.007.
That is James Bond, right? That is 0.007, right? 007, 007, okay? So now this one, if you deconstruct, this is this 3 and this 3. Do all of you understand this very clearly without any doubts?
Yes, sir.
I want to see yes or no. Either yes or no from everyone. Binary. We are into binary. Okay.
Yes, sir.
I'm waiting for that one no. No? Oh, okay. All of you. Okay, fine. Right. Okay, so this is what we call as base 10. Good. Now we moved on. So what did we say now? Same system here. Instead of 10, it is 2. So we told this is 2 raised to 0. So value is 1. So what is its value? Its value is 0 into 1 or 0. Second position, 2 raised to 1, 2. So its value is what? This position's value, place value?
2 into
1.
1.
1 into 2 or 2. Third position, 2 raised to 2. What is its value?
4.
0.
Place value is 4. You are right.
0.
Yeah. Place value is 4. You are right. But because this is 0, just like our previous case that middle position was 0, it is 0 into 4 or 0. What is this value?
8.
1 into 8 or 8. What is this value?
16.
1 into 16 or 16. So totally, what is the value of this expression? This in binary means what in decimal?
26.
26, right? It is just simple addition. So this is what we call as base 2, right? Then we also told one important thing, right? With 2 digits in binary, the largest number you can represent is this one and this one. That is 2 plus 1, 3. So if your binary number is 4, you need third point, three digits you need, right? If with 4 digits, 1, 2, 3, 4, if all are 1, that is the biggest number with 4 digits. What you can represent? 8 plus 4 plus 2 plus 1, that is 12 plus 2, 14 plus 1, 15. If your number is 16, you need the 5th decimal, right? So with four points, the largest number you can represent is 15 or 2 raised to 4 minus 1. Do you all get that also?
Yes.
Yes, sir.
Yeah. So 2 raised to n minus 1 is the largest number you can represent. All of you, do you get this, understand this expression called 2 raised to n minus 1? So now you see this also you understood. So I gave you 2 problems. Tell me what is the value of this expression now?
Nine.
This is something which we did in last one, right? 1 plus 0 plus 0 plus 1 into 8. So this is 1s, this is 2s, this is 4s, this is 8s. Just like how we tell 1s, 10s, 100s, thousands. Right? So what is the value of this one? You calculated last time?
26.
All of you agree?
Sir?
All of you agree to this, his value? This figure? 26 is telling you.
No, not 26. 1 minute.
48.
Calculate.
27.
Just put on the top of this its place values. Best way is to put on top of this place value 1, 2, 4, 8, 16, 32.
$51.
51.
So why did you make a mistake first time?
So I was looking in my book. I made a mistake last class.
Okay, and you repeated. You want to be consistent, right?
No, sir. I just looked there. I forgot to write the correct answer.
Okay. I thought you want to be consistent. Last class also you made a mistake, so that you feel nostalgic today. So that last class also and this class also. Okay, so don't make such silly errors. Always the best method is write on top of this the position. This is a common thing which you will get across. So write on top of this the positions 1, 2, 4, 8, 16, 32. Don't do it in mind. Don't do it in mind. You will make errors. Okay. Everyone get this?
Yes.
Yes, sir.
Okay, so now this is something which we covered. Then I told you, I gave you this assignment. Then we told about this. Just a random number. We took a decimal number. to see how it is represented. So we told 2.7. How do we represent that? This is decimal, okay? Because this is 2 and 7. So how do we represent that? Where does 2.7 fall in this picture? Mark it.
Between 2 and 3.
Between 2 and 3, right? How do we know where in between 2 and 3?
Divide it in 10 parts, then the 7th.
Why divide it to 10 parts? Why not
10
100
base
parts?
system.
Yeah, this is 10 base system. So you divide this into 10 parts. After the decimal, first position is what? 1 by 10. 1 by 10 means what? 1. You divide into 10 pieces. So here the 1, between 2 and 3 the value, between 2 and 3 is 1, between 3 and 4 is 1, between 4 and 5 is 1. 1 by 10 of this means this 1 centimeter or 1 meter or whatever this 1 unit is, you divide it into 10 parts, right? So these parts will be, what will be these parts? 2.1, 2.2, 2.3, 2.9, 2.93. You all know this. And 2.7 will fall here. All of you know this, right? Okay. So what if this specific, I take this one like this diagram. What is this value? This is 1 by 10. This is 1 by 10. This is 1 by 10. That is the first decimal value. What if you have one more decimal, 2.74? Now 2.7 is this. What is 2.74? Where will that fall?
Between 2.7 and 2.8.
Between this and this. So what did this 4 do to this value? What did this 4 do actually?
Divide it again to 10 more.
10 more parts, but what did it actually do? What is its utility? What is its function?
To get more accurate.
To get more accuracy. The actual value of this is not here. This was an approximation. Okay. So actual value you want to get means you are getting into second position, which is 1 by 100. 1 by 100 means what? This whole between 2 and 3, you are dividing into 100 pieces. You first divide into 10 pieces. Now you are dividing into 100 pieces means what? Each point between 7 and 8, you are dividing into 10 pieces. 8 and 9, 10 pieces. So totally 100 pieces. So between 7 and 8, if you divide into 10 pieces, this 4 will fall where? 2.74 will fall where?
The fourth one.
In the fourth place, right? Approximately here. What if I have one more digit?
1000 divisions.
So what you will do? Which you will divide? Here we divided between 7 and 8, like Avinash told, we made 10 divisions.
2.74 and 2.75.
Yeah, like Adnan told, between 2.74 and between 2.75, between 2.74 and 75, you will make 10 more divisions. Between 2.71 and 72, you will make 10 more divisions. Between 2.21 and between 2.22, you will make 10 divisions. So totally you will have 1000 divisions between 2 and 3. And in that divisions, the 8 will come in the 8 point. You understand this?
Yes, sir. Yes, sir.
Exactly. Yeah. So all of you get this. Now let us get into, this is like bit more accuracy increase, bit more accuracy. One more decimal means, one more point means accuracy increases bit more. Like somebody told, magnify it. Yeah. Okay. Now get into the binary business. Let us assume there is a number like this. Okay. I'm not talking what is on this side. It can be 2 or 3 or 5 or 10, something. Or 0, something. But this is just like 0.7, just like we know, we mark now 0.7, right? It is just like that. One number, or 0.75 or 0.78 or 0.7932. This is the binary representation of some decimal number after the decimal point. Okay. Now let us find out where this will fall. Assume this is 0, 0.11101, right? So now, what is the first position? 2 raised to minus 1, right? Or 1 by 2, right? Before it was 1 by 10. Now it is 1 by 2. Where will it fall? Assume this is 0, this is 1. So now how many divisions you will make here between 0 and 1?
2.
2. Before you did 10 because it was 10 piece. Now you don't have numbers. You don't have characters to represent nine different species. You have only 2 species here, 0 and 1. So you divide this into 2. Where will this fall? This half means what? Half is which point? Half is this point, right? This is 0.5. If this was 0, it would have been here. So this is 1 means what? This is 1 means the value is half. It also means the value lies between this and this. But our accuracy is only this much now. Our answer with 1 point after the decimal can vary. If the value is 0.99, let us assume. If this was slightly before 1, 0.99, still we can represent it only 0.1. In decimal system, if it was 0.99, you could have represented it as 0.9. So the accuracy comes to 1 by 10. Here the accuracy comes to 1 by 2 only because you have only 2 numbers. Understand?
Yes, sir.
Right. So now this is value is 1 by 2. So our point is here. Now the second point is 2 raised to minus 2. That means 1 by 4. So if we divide this into 1 by 4 means what? Between 0 and 1. Previously, each point, this and this you divided 10 times. This and this you divide 10 times. Now, this and this we will divide 2 times. This also 2 times you will divide. This also 2 times you divide. So this value, this point is 0.75. So the whole between 0 and 1 you are divided into 4 pieces. 1 piece, 2 piece, 3 piece, 4 piece. Where will our value, where is our point? 0.10. Where is our point? Where will it stand now?
Between 0.5 and 0.75.
Yeah. So as of now, it is between 0.5 and 0.75, but our value is only 0.5 because this is 0. This is half plus 0. Is it not? This is half plus 0 because this is 0 into 1. 0 into 1 by 4. So we know it is between this and this, but with 2 decimals, we can only tell this is between this and this, but our current value is 0.5. So our accuracy now is improved. Before it was 0.5 was the accuracy. Now our accuracy is 0.25. It is improved, but still it is not great. It can be anywhere here, but the current value of this expression 0.10 is half only. It is here only. Do you get that? Do you get that?
Yes, sir.
Yes, sir.
Yes, sir.
Next point is 2 raised to minus 3, which is 1 by 8. Now you are dividing this into 8 pieces. So 1 piece, 1 division here, 1 division here, 3 more division here. So each of this point is 1 by 8. So this is 0.5, 0.625, 0.75. Where does our value stand? That is again 0 because this is 0 into 1. So this doesn't move. With 3 decimal points, 0.100, our accuracy has but improved. We know now it is between 0.5 and 0.625. So even if the value is 0.624, we miss it only by 1/8. Our accuracy has improved with 3, right? One more point, that is 2 raised to minus 4 or 1 by 16. You divide it into 16 pieces now. This whole 0 to 1 you divide it into 16 pieces. Where does this stand? Did the value change now?
5.62. For 0.562.
Yeah, this will change, This will change because now you are having a one value here. This is plus 1 by 16. That means this value is between this and this now, between this 5.5625 and 0.625. If this was 0, still this would have been here. Now as this is 1, this our value shifts to this point now. Do you all get this?
Yes, sir.
Yes.
So now if you add one more decimal, we will know between this and this, where is it? We will divide this into half, which means that position is 1 by 32. That means we are dividing this into 32 positions. Our accuracy will improve. Do you all get this? Anyone has a doubt?
Got this, sir.
Everyone?
Yes.
Anush, do you get this? Ritesh, Anush, Navjit?
Yes, sir.
So now, what is this value? We just 1 by 2 plus 1 by 16. If to add, you have to bring both into by 16. We learned it in the first class. So this will become 9 by 16. Isn't this not 9 by 16?
Yes.
Yes.
Because we have divided this into 16 pieces. This is the 8th piece. This is 9th, 10, 11, 12, 13, 14, 15, 16. I haven't marked everything. So this is the 9th piece, right? The same value. So this 9 by 16 is the decimal representation of this figure. Let us assume you have some kind of a house plan and you want to mark a pillar here. Assume this is 0 and 1, this is 1 kilometer. So your architect has drawn this and told you mark the pillar here. So how you will do it? You will divide this into 16 pieces and the 9th piece you will go and mark. So the representation of that in decimals is this. Representation of that in binary is this. This and this are 3 forms of representations. This is graphical, this is decimal, this is binary. Do you get that?
Yes, sir.
Yes, sir.
And same thing can be, if this was Sumerians, what they would have done?
60 based.
They would have done the same thing with 60 base. In their clay tablet, if you go and search, you see they have marked root 3, root 2, everything like this, but it is not 100, it is in 60 base they have done. So all representation of real life scenarios. Okay, but in computing we do this because of a handicap. Because in computing, it is best to use this system, but we have limitations in the electronics of computer, and this is the best system which we follow, so we can use this. Okay. Now, calculate the value of this.
Five.
0.0101, is it 5?
Oh, sorry, 1 minute.
So you have to be very careful while you do such problems. Okay, don't jump out and tell. In maths, most of the time you will make such mistakes. So do it and carefully and analyze yourself. In this class, it's okay, but if you are doing in exams,
5 by 8.
okay, I will listen to everyone.
Sir, doubt. Not regarding this, but future could be used rather than binary. The 10 base system could be used for computing.
It is very difficult to use 10 base systems because the computing works based on the characteristics of some elements like silicon and all on their ability, like what we call as data. is a ability of this to have a charge. So charge is there, it is 1. Charge not there, it is 0. So because though we tell numbers, digital and all those things, actually everything is analog. Hardware, it has to work in hardware, right? Whatever digital you tell digital and all, it has to work in hardware. Okay, so hardware, you can't, for you to have 10 different states is nightmare. You don't have such material systems as of now. Go home and draw this also, okay? That mark between 0 and 1 or something, and mark where will it fall, so that you will get an idea. As this is 0, is it in the first half or second half?
First half.
It is first half, right? If I draw between 0 and 1 like this, and if I tell this is the center point, this is in the first half, right? Because this is 0. Now for the next one, this is 1 by 4. So this is
This is 5 by 16.
Yeah. So this is second half, right? This is second half because this is 1. Now again the third one, 0, means what? This is this half. This is the fourth one, 1 by 16. That means here. You see, as it is 5 by 16. This is 1 by 0 into 1 by 2 plus 1 into 1 by 4 plus 0 into 1 by 8 plus 1 into 1 by 16. Is that how you all got?
5 by 16.
Yeah, 1 by 4 plus 1 by 16, right? So 1 by 4 is 4 by 16 plus 1 by 16. Did you all get like this? This is also by like this also you will get. This is the way to validate it. Did all of you get it?
Yes, sir.
Is there anyone who doesn't understand it? Avinash is consistent.
Sir.
Yeah, because he's in a hurry. He knows it, he's in a hurry. That's why he makes mistakes. Yeah. Yeah. Yes.
So what
Satish.
is the answer? Can you repeat again? I'm in a mobile too, so I can't hear.
So this is, what is the value of this piece now? First piece. Somebody explain it. Adnan, please explain it. How did you get it?
So the value of the first one, 0, is 1 by 2. But 0 into 1 by 2 is also 0, right? So we go to the next number is 1 by 4. So 0 plus 1 by 4 into 1 by 4, which is 0 plus 1 by 4. And then the next number is 1 by 8. And then, which is 0, multiply, you can still get 0. That plus the last number, which is 1 by 16. And 1 by 16 into 1 is 1 by 16. You add all of them together, and then you get 1 by 4 plus 1 by 16. And when you take LCM, it becomes 4 by 16 plus 1 by 16. And then when you add both of them, you get 5 by 16.
This is what Adnan had told. All of you agree? Do all of you get this?
Yes, sir.
Do you know to mark it now? I want all of you to mark it. Yes.
Marking on the line is what makes me a little bit confused.
Okay, so let us do it once again. Marking on the line, let us do it once again. See, let us assume this point is 0 point something. So that means we will mark a line. Let us assume this is 0 and this is 1. Yeah. Okay. So what is this first point? This is 1 by 2. You are dividing this into, this position is 1 by 2, right? Agree? So 1 by 2 means what? You are dividing this into half. As this is 0, this is falling on this position. Do you agree, Adnan?
Yes, sir.
Yeah. Adnan, do you agree this? Our value falls on this position. Now the second position, as you told, is 1 into 1 by 4. That means you are dividing the whole piece into 4 pieces. Now you are dividing the whole thing into 4 pieces. 1, 2, 3, 4. Your position was here. First position is 0. Your first one is 0. So your position was here. Now the next one is 1. Once you divide it into 4 pieces, that means you know it is either between this and this, or it is between this and this. The first 0 tells you your value is between this and this. This is what the first 0 tells. Right? If this was 1, it would have been meaning like our previous number, the value is between this and this. So now we know our values between this and this. This is 0, this is 0.5, this is 1. Now the second one tells you are dividing this into 2 parts. Second one tells this the value is 1 by 4. So your value moves here, shifts here. Do you get that?
Yes.
Now the third one says you divide this into 8 pieces. 1, 2, 3, 4. So now totally how many pieces? 1, 2, 3, 4, 5, 6, 7, 8. So each piece is 1 by 8. Right? Right? So our value is now either between this and this, or between this and this. But because it is 0, now we know our value is between this and this. So it has not moved here only. Now the fourth one tells you divide it into 16 pieces. So you divide into 1, 2, 4, 8, 10, 12, 14, 16. So whole piece you divide into 16 pieces. So we know our values between this and this. In this, the only question is whether it is between this and this, or this and this. Now we know as it is 1, we know this our value is between this and this. But so this is the point. As of now, what we have got, this is the point. What is this point? From here you count. This is divided into 16 pieces. This is 1 by 16, 2 by 16, 3 by 16, 4 by 16, 5 by 16 is our point. Now this could be a bit tricky. The only way is go home and do this. Yeah?
I see.
But if you do this, that means you have understood the crux of it. If you know this also, you know the crux of it. That means you are ripped apart binary and you know the crux of it. Right? So spend time. If you've got a reasonable grasp, spend some time on this. And many students, maybe in much higher classes also, may not know this. Okay.
Yes, sir.
Go home and try doing this. Okay? Go home and try doing this and upload it in the site. Both pictorial and algebraic. Algebraic is easy. Okay? But if you get it graphically, only the knowledge is complete. Because the real life is graphical. Algebraic is only an expression. Algebraic, you will learn all these things in school, you will understand, but you won't know what is happening behind the scene. So if you make it graphically, you will know what is happening behind the scene. Yeah? Okay?
Supposed to do the second one now?
Not now. It will take time. Go home and do it. If you have doubt, you ask next class. Okay? Right. Now.
You have to write?
No, don't do anything. Now, till now what we did, we took a binary value and we are seeing what is its decimal value. It's after the decimal point and before the decimal point, right? Both are same technique. You have to know the place value of it, calculate and add, right? If you get a binary value, you have to get the place value of it and add all the place values. You will get the decimal value, whether it is after the decimal or before the decimal. Only place values change. Now I am asking you, represent decimal to binary. How will you represent 6 in binary?
So I have studied a little bit. Divide it by prime factor by 2.
Yeah, you know
and
why?
take the reminder.
You know why do we do it?
No, sir.
Yeah, so that's
He
what we
just
are.
taught me. We
Yeah,
learned.
yeah.
0, 1, 1.
Yeah,
0, 1, 1, right?
Yeah. So now you see, is it 0, 1, 1? If it is 0, 1, 1, it would have been 2 plus 1, 3. Yeah, no?
1 0.
0, 1, 1 is 6, right?
0, 0, 1, 1. This is the value, you see, place value. So you are telling 0, 1, 1. So this would have been 2 plus 1, 3 if it is 0, 1, 1. So please understand, 0, 1, 1 is as good as 1, 1, right? There's no value of 0 on the left side. So with 1, 1, with 2 decimals, you can't represent 4 and above. 4 and above to represent you need 3 decimals. 8 and above you need 4 decimals. 16 and above you need 5 decimals. That's what we learned, 2 raised to n minus 1. So how do you represent 6?
When 0 comes, it's 1, right? Because the 0 is the first one, the place.
Yeah, when 0 is the first place, it has no value, right?
So 0 itself, right?
0? Just think. See, when you tell an answer, you yourself, now you know when you get a binary value, how to calculate decimal value. You did all this now. So when you tell a value, you yourself calculate and see, are you getting 6?
110.
110 is 4 plus 2, 6 plus 1 plus 0, right? See, what Shivananda told is 1, 1, 0. That means 4 plus 2, 6.
Oh, I
plus
see.
0. Yeah.
I started right. I started from the right. I supposed to start from the left.
Exactly. You see, that is why I was giving you a clue. You see, if it is 4 and above, you need 3 decimals. So if it is 4 and above, you need this decimal, 4. So this is 1 for sure. Then you have only 2. After 4, if this is 1, this is 4, then you only 2. Then it is next is 1. Right? Do this. See, think about it. If it is 16 and more, you need 5 decimals. This point as 1. If it is 32 and more, you need this as 1. So this is more than 32. So this is 1 for sure. Then next one you see, can it be 1? If it is 1, then 32 plus 16, 48. No, it can't be 1. Then can it be 1? Yeah.
So the answer is 1 1 0 1 1 0.
I will write 1 second.
1 0 1 1 0 1.
Tell the number.
1 0 1 1 0 1.
1 0 1 1 0 1. Okay. So this is
Yes.
ones plus 4 5 plus 8 13 plus 32 45. So how did you do it? You do it like, you know, if it is 32 and above, you need this place to be 1. Okay. So that is how you write it. Like if this is 32 and above, then this place is 1. First place is 1. Is it not? Now you see, if it is 64 and above, you need this position to be 1. Now the second point, can this be 1? No. Why? 32 plus 16 is 48. It is bigger than this. So we know now this is 0. Right? Now the next one, can this be 1? Yes, it can be. 38 plus 8 is 40 only. So we put this as 1. Right? So this is like this. We see now, can this be 1? Yes, 38 plus 40 plus 4, 44, and this, yes, this can also be 1. That is 44 now we have reached. Can this be 1? No, 44 plus 2 is 46. So we don't have that much value. So this is 0. Right? You all get this? This is how you all of you did it, right?
Yes.
Yeah. So now the last one is 1. right? This is how all of you did it. Do all of you get this? This is how we do it by trial and error. This method, what you did is called trial and error, right? Right? How do you do 100?
Yes, sir. 11001.
What will be this position? 64 position?
1
It will be 1.
1
Then this
one
is
one
also,
zero
yeah.
zero one
100100.
Yeah, so you see this position is 1 because anything above 64 you need this to be 1. After this is 128, this is less than 128. So you know this is 1. Is this 1? Second one?
Yes.
Yes, so you got 1, 64 plus 32 is 96. Then you know you have only 4 left here. So this is 0, this is 0. Then this is the only thing 1. These all are zeros. Do you all get this?
Yes.
Yeah. So now this is only to get an understanding. This method you can never use, right? What if you get a huge number, x, x, y? What if you want to write a computer program? Can you tell, oh, look, whether it is bigger than 32, look, it is whether than bigger than 64? This is not a method. This is called trial and error, right?
Yes, sir.
So now you design a method to replicate this. Whatever you did now manually, design a mathematical method which will hold good. How can you do it with an automatic method? How can you make it a standard method with which you can write a computer program, you can tell computer, or you can tell somebody any number you get, this is the method. Like rather than this, you look whether it is greater than this, then you take that, then take this.
Divide by the base.
So what will happen? If you divide by base, what will happen?
We'll get a reminder.
So
it we could place the value 1. Then why I don't know.
Ah, okay. Okay. Think about it. Apply your brain. For example, how you look at a method, I will tell you a simple example. Okay. Look at this. See, what did we say? If we have a number called 6473. Okay. What is its meaning? So this meaning of this is, what is the meaning of this? 6,000s, right? 6,000s plus 500s plus 7 tens plus 3 ones. This is what is the meaning of it, right?
Yes.
So how do we add this? So we make a method, right? We write this 500 below this like this, right? Below this like this. This 5 below its position, 0 below its position, 7 below its position. Then what we do? Then we write 70 below its position, right? When you add it, that's how you add, right? And 3u its position, right? So then how you normally add? You add all the ones right below, and below this you write the answer. You add all these threes, and then right, if you have a carry, you take it to this 10th side, then you add this. That is how you add, and this is a standard mathematical operation. You can do this, you can deploy it for any numbers, right? So multiplication, how you do? You have a method. Multiply first with the ones, write it, and multiply with tens, write according to place value. Multiply with hundreds, then you add all those. That is called a mathematical method. How can you design a method for what you just did with trial and error?
No idea.
No idea. Did you try?
I did.
Okay. Anyone else tried? Anyone gets a spark? Okay. Now listen. Listen carefully, okay? Everyone listen carefully, okay? This is not developed by me. Somebody had developed it. Okay, I'm just making you think. That's all. Okay, take 6. Okay, now divide this with 2, because why with 2? 2 is the only thing we know in this business. We don't know whether this number is bigger than 64, 32. That we know 6, so we know it is more than 4. We know 47, so we know it is more than 32. But if it is an unknown number, x, y, we don't know. But we know this 2 is correct because 2 is our base. We are playing with binary, so 2 is base. So when we divide this 6 with 2, what happens? We get some value. And we get, we get a remainder called 0. What does this remainder mean? Remainder 0 means what? Remainder 0 means, if you observed, only for odd numbers, you will have the last point as 1, right? Because in binary, the last point is ones. If it is 2, you will have the 2 decimal as 1. If it is 3, you need it is 1 1. Because the last one, if it is 3, you need that last one as 1, bit as 1. If it is 5, you need that last bit as 1, because that 1 cannot be represented by 2, 4, 16. See, after the last bit, everything else are even numbers. 2, 4, 8, 16, 32. So if you have an odd number, then only that last binary bit will be 1. Agree?
Yes, sir.
Right? So if you divide it with 2, if you get 0 decimal, that means our last bit is 0. It is not 1. If this was 7, we would have got a decimal. If it was 9, we would have got 1. If it was 133, you would have got 1. You all get it?
Yes,
Yes,
sir.
sir.
So we got our 1 bit. Okay. Now we divide this again by 2. What are we actually doing? If you divide this by 2 and whatever you get again divide by 2, what are we doing?
We are putting a point, right? Decimal point.
Okay.
No, we'll put 1.
Okay. What are we doing? If you decide to divide this by 2 again, what are we actually doing?
Find the next place. Also find the previous place.
You are looking at getting an answer. Forget about answer and all. Just look at what we did till now. We divide 6 by 2. So we got 3. We are dividing.
Divide hundreds place like tens for the 100 place here for the next fourth place.
There is no tens and hundreds in binary band. This is binary.
For the second place.
Second place is what place?
2.
Are you sure? Is it 2? Yes, it is 2.
1. Yes.
But you see now, you divide 120. You divide 120 by 2. What value you get?
60.
You divide 60 again by 2. What you get?
30.
So what you actually did to 120?
Divide by 4.
Simplified it.
Divided by
Divide by
4. Because you are dividing 2 with 2 times means you are dividing 6 by 4. So whenever you divide this again, whatever decimal you get, 1 means what? This 1 means what? 6 has 1 4. That's what it means. Right? You are divided 6 by 2 once. You are dividing this by again 2 means you are actually dividing 6 by 4 and you are getting an answer as 1 means this 6 has 1 4 and you are getting the remainder as 1 means what does this mean? What does this remainder mean?
So, like when we get remainder 1, that means the decimal, the binary number is Finish.
Forget,
Like
forget,
we
you
can't.
forget about binary. You forget about binary. You just think decimal.
Odd
See,
number.
forget about odd. See, here you got 3 means this is 0. Here you mean, see, 1. Why did you get this 1 decimal? In this 3, only 1, 2 is there. So only 1 is left. So this 1 of what? 1 of this 3. But this is not 3. This is 3 into 2. This value of this is 3 into 2. So this one value of this is 1 into 2. Right? So what does this mean? This means 6 has 1 4. And after 4, 1 2 is left. 4 plus 2 is 6. That is what this means. Just read it. With your calm mind, forgetting about all your decimal, binary, all your intelligence and huge knowledge of mathematics, physics, chemistry, all your great intelligence, leave all those things aside. Look at this very simple thing and see, is this not telling 6 has 1 4 because you divided it by 2 2's, and it after that 1 2 is remaining. This is a great principle. If you are dividing one number by 2 times, or if you divide this with 2 and 3 again, actually you are dividing this with 6. If you are dividing this with 1 and again 3, you are dividing this with 1 into 3. So actually you are dividing this 6 by 2 into 2, 4 means, now you got in this 6 there is 1 4 and 1 2 and 0 ones. No ones you have left. 4 plus 2 is 6. If you tell yes, I want to move. Where did Shivadanda go?
Yes, sir.
Shivadanda, okay?
Yes, sir.
Okay. Now, so now decimal 6 means binary 1 1 0. What is this 1? 1 is 4. We told 1 is 4. This is 2. This is 0. 4 plus 2 plus 0. Okay. Now Avinash wants to take larger numbers. Let us take large number. Okay.
So is this what you told us to figure out? 110.
Yeah, 1
Was
1
that
0.
what was?
1.
But you said to forget about binaries.
No. Okay. So I am not talking about binary till this point. Till this point, no binaries. Right? Yeah, Adnan. Now,
Yes.
now I am telling this says 6 has how many 4s? Actually, what he asked is a good point. Okay, and this says how many 2s are there? Because this position is 2, because you are divided this with 2, that means 3 is 3 into 2, 6. 1 is 1 into 4. So now this expression tells 6 has 1 4, 1 2 and 0 ones, which is actually our binary system. We are looking in binary, how many 4s, how many 2s, how many 1s are there. Right? So by doing this decimal operation, we are getting the binary value. This, what does this mean? This 1 means how many 4s are there in this number, that is this. This means how many 2s are there in this 6 one, that is this. This means how many 1s are there in this, that is this. So this decimal operation, we are converting into the binary meaning of it now. So from this decimal operation, we understand that this, if we take, this is the binary value. Yeah? Let us take 45. Okay? Divided by 2. You get 22. You get 1. What does this 1 mean?
There's 1 to...
Yes. So this, what does this expression mean? This 22 and 1 and all, what does it mean?
There are two 22s plus 1.
There are 22 2's. There are 22 2's in 45 and 1 1 is left. right? And this, this one we know will not get changed because this is an odd number. And if it is an odd number, you need that last bit of binary. Now what we do? We divide it again by 2. So we get it 11 and decimal. Now what does this mean?
There's
11
11 twos in 22 and 0 ones.
Yeah, but we are not bothered about 22. 22 is not a
11 fours.
our man is 45. 22 is only an interim stuff.
There's 11 fours in 45 and 0. I don't know.
Okay, so you're right. Yeah, there are 11 fours in 45, which is what? 11 into 4, 44. Then you don't have any further twos.
0, 2, yes, in capital.
Right? 11 into 4 is 44. Then you don't have any twos, you have only 1. So that is 11, 44 plus 1 is 45. That is only what you have written here. But we understood one thing. The binary representation of this number will need a 1 bit on the one side and a 0 bit on the two side. We don't need 2 bit because we can represent it with 4s. But we don't know what is going to be in the 4 bit. If we can represent this entire 4 by 8, then 4 won't be there. And if the entire number can be represented by 16s, then 8 won't be there. But 2 we don't need for sure. But if something can be represented by 4s, you don't need 2s. Right?
Yes, sir.
You divide it again by 2. So you get 5, remainder as 1. What does it mean now?
5, 8, 1, 4 and 1, 1.
Yeah, so see what you did? The entire 4, see we can't use this 11, right? Our binary system has only 1s and 0s. So we'll do this till we get 0, 1. So now we understood 45 has 5, 2 into 2 into 2, 5, 8. 2 into 2 into 2 is 8. So 45 has 5 8s, 5 into 8, 40. After that, we need 1 4. Becomes 44. We don't need 2. We have decided. First itself we told 2, bye. But we need this 1. So now we know in this number 45, if you are representing in binary, we need which position? The 4 position. The 11 is what? This is 4. 11 fours. 22 is what? This is 2s. 22 2s. So we know in the 4 position we need 1. In the 8 position we don't know. So this is 5 into 8, 40 plus 44 plus 145. Right? Divide again by 2. We get 2 and 1. What does that mean now?
2, 16, 1, 8, 1, 4, 0, 2, 1, 1.
Yeah, so we need to, we have now got 2 into 2 into 2 into 2 is 16. So 2 16s. 2 into 16, 32. But we need 8 because 32 after 32 there is 13. 45 minus 32 is 13. So to represent 13 you need 8.
1 8 because all these 2 combined is 8.
Exactly. This 5 is 8s actually. 5 8s 40. This is 4s. This is 2s. So you need 1 8. So 2 into 16, 32 plus 8, 40. Then previously 44 plus 145. Can we use this? No. 2 we don't have in binary. So we have to again divide it till we get either 0 or 1. So we get 1. Remainder is 0. Which means what? 16, man, bye. We don't need you. 32, if it is 2, 16, means what? 32, we have 32. We don't need 16. So this means 45 has 132. Why 32? 2 into 2 into 2 into 2 into 2, 2 raised to 5. We have 132, 0, 16, 1, 8, 1, 4, 0, 2, 1, 1s, which is this. Do you understand this?
Yes, sir.
See, this you will learn. That by dividing 2 is how you do it. But you have to understand what is happening inside numbers. Okay, so do these two at home. Okay, just doing this divided by 2 is very easy, but understand the meaning of it. And after getting the value, convert it back and see whether your answer is right.